Welcome everyone. Our project is statistical analysis of COVID-19 dataset. This is Sanjana.
So, hi, this is Janavi Vardhan. Now we are discussing about the analysis of the dataset of COVID-19.
Yeah,
So, first,
show the dataset, Janvi.
the dataset of includes location, country, gender, age, and dates of symptoms onset and hospital visit and exposure date. With also we have source and link in the dataset. And we have considered with visiting Wuhan from Wuhan death and record with zeros and ones for accepting and not accepting. So
Yeah,
we
the
can
main inference is like to find out which age group and like men or women is going to be dead very much by this COVID.
yeah. So first we'll start the analysis of the statistical analysis of the data. After importing the basic libraries, we'll show the structure of the data. And then if we consider the death rate to in the basics, we have 0.05 and the frequency of the death rate is regarding the here. These are all the frequencies and percentage of the death rate. Since we are considering the deaths related to the gender and the age, we have the percentage of the deaths. And comparatively, we use ggplot for performing the graph task. So the gender claims in here is this is a graph related to the country. So which countries have more cases, and then these are all the related graphs according to the countries. So we related to the age. This is the density plot, and with regarding to the age of the density plot, this is the bar graph and this is the frequency graph. And so we came to the main part. So we had the claim is that to check whether people who die is older. So since according to the our data set which we have, if we find to find it, we are using the t-test. So if you find the t-test algorithm configuration level of 0.95, we got values like 68 and 48. So we can find that these two values have 20 years of age gap between who are dead and who are alive. So we can conclude that who are the people who are dying for the coronavirus attack is mostly who are older. So this is the final and then final difference is around 20 years. And then so we are checking it whether it is statistically significant or not. So we can find out that with 0.95 configuration level, we can find it is it is more significant. So since p value is very less than 0.0 points, and then these are all the BW plots. The other claim is that gender has no effect regarding the death, but we can show from here if we show mean value of if we do the t-test for the men and women, we could find the difference is around 0.084, like 84% for the male and 36% for the female. Since by this conclusion, by this values we could just conclude that we have a difference of some it varies a major difference. So we could mainly tendency for the death rate for the male is more. So we can just conclude that the female has more tendency for the death rate due to the attack of COVID-19. So now Sanjana will explain about how we have done the forecasting for the data set.
In this forecasting, we'll majorly know about the machine learning algorithm of the random forest. Um, like these are the libraries install the tidyverse and all, and this are the major things for reading the data set which we use in the machine learning thing. And it goes these are the data types which are used, and this is the province states which they have used, and this is the categorical data. uh, and these are some of the missing data sets which we regard to that. And this shows which what is the country, region, date, etc. And And next, uh, we go to the tail version. The tail explains what are the last six digits which are involved in this, and this columns is used for the to find the missing values of the particular data set. And these are the things like this is the major graph we have drawn from this. Like these are the COVID-19 cases which are indicated in the red mark, and these are the fatalities. Fatalities respond to the death rate. Death rate is very low when compared to the cases. So this is the inference from this. And the next thing is we have grouped the training and test data sets. And the next thing is we are going to check the confirmed dates with regarding to the countries. By this we come to know that United Kingdom and US have major cases in this. Um, and then we create the long format for this. And this is the bar graph which we denote the confirmed cases as we have earlier did some graph. This is the bar graph. And again, we create the long format for this. And yeah, it goes on like here we find the province states. Yes, here we see the total number of states which we have taken, that is 312. And here we see the confirmed cases, fatalities according to their boxes. And the next is like we do the forecasting. The forecasting is the major thing that we have done here. This is the machine learning algorithm we have used here. Like this forecasting, by this we can get the RMSE values. The RMSE values are very important. Like the root mean square values adds the difference that is between the actual and predicted. Like whatever the predicted value according to the data set, whether it is right or not, we can know by these RMS values. So we have found out this. And for the major of the countries, it has possibly like uh, near to zero, so that like we can conclude this model is very accurate, and like um, the tests are not very good. And this is all about our project. And the final inference is like we have done three things. We have found out the
Well,
people who are dying according to their ages. And the next thing is like whether men or women are dying. And the third thing is we have found the RMSE values. Janvi, can you
yeah.
add the inference?
Uh, so yeah, this is like we have found RMSLA values and with 312 countries which we have considered in the data set, and then we have found out the two claims were right or wrong. Yeah, that's it. Thank you.